Oh yeah, I can hear you.
Yeah, welcome Team IAPE 54 to the Global Youth Science and Technology Bowl 2020. This team is from Ireland. The project title is the Microplastic Filter, a small solution to a global problem.
Yes.
We'd like to thank you for attending the online judging today and for your efforts made in the past few months. Today, we're happy to have Professor Ho from the Chinese University of Hong Kong, Dr. Chen from the City University of Hong Kong, and Professor Loss from the Hong Kong University of Science and Technology to be judges of today's competition. You'll have 5 minutes to present your project. When time is up, you will stop your presentation. After that, there will be a 4-minute Q&A section. You'll be able to see a timer on my screen later. So please share your PowerPoint if you have one, and then tell me when you're ready to present.
Can you see it?
Yes. So ready?
Yeah.
Okay, we start.
Hi, I'm Ruth Madden. I'm 17 and I'm from Ireland. Today I'll be speaking about my project, the Microplastic Filter, a small solution to a global problem. The United States National Oceanic and Atmospheric Administration describes microplastics as the most prevalent type of marine debris found in our ocean. Those that are less than 5 millimeters, 5,000 microns in length, are called microplastics. There's increasing scientific concern about the effects of microplastics on the environment. The bulk of microplastics found on global shorelines are materials used in synthetic textiles. Internal washing machine filters do not intercept microplastics. Incomplete partitioning at wastewater treatment plants results in the ongoing release of millions of microplastic fibers into watercourses. Therefore, the project objective was to design an innovative filter to have the capability to filter out microplastics as small as 100 microns, utilize permanent filters, allow for retrofitting to existing domestic wastewater infrastructure, and be of low cost. The overall design conceptualized wastewater entering the inline filtration unit from the top, flowing through a number of stacked filters and exiting the unit from the bottom. The use of angled filters in tandem with gravity and water flow pushes the intercepted particles downwards along the filter, aiding self-cleaning. I developed the project in stages: constructing, testing, and critical assessment of a concept prototype. Stages 1, 2, and 3. Stage 4, the redesign of the filtration unit based upon the analysis of the concept prototype. Principally, reduction in filter pore sizes based on flow analysis, and laser cut acrylic for unit housing to enhance unit integrity. Stage 5, the construction of a balsa wood 1:1 scale model. Stage 6, the construction of the final filtration unit as indicatively shown in the following images. Here we can see the final filtration unit ready for testing. Stage 7, testing of the filtration unit. General test protocol. So a Bosch automatic washing machine was utilized for all tests. Each test was preceded with 5 different samples of microplastic. Each sample had 200 particles. The machine was set to a short main wash cycle comprising 2 sub-wash cycles and a final 400 RPM spin cycle. The main wash cycle was run consecutively 4 times without the introduction of further test particles. The wastewater from each cycle was collected and filtered. The recovered microplastic particles, if any, from each cycle were separated according to colour and counted. Additional test-specific protocol. Test 1, no filtration unit, the control, and Test 2 with the filtration unit. The results of Test 1, the control, no filter. Stage 8, observation and analysis. Here we can see the recovery of both seeded microplastic particles and other non-seeded fibers. 92.9% of the seeded microplastic particles passed through into the wastewater within 4 wash cycles. The smallest particles, green, passed the machine most quickly, 87% in the first cycle. The heaviest particles, yellow and black, passed the machine next most quickly, with 77 and 63% respectively in the first cycle. The longest particle, blue and orange, were the slowest to pass through in the first cycle at 50 and 34% respectively. Statistical analysis of the test results indicates that ultimately, unfiltered, a microplastic particle, irrespective of size, weight, or shape, will pass into the wastewater. Results of Test 2 with the filter. Here we can see the various filters ranging from 5,000 microns down to 74 microns. Here we can see the particles used to seed Test 2 and the used fill paper of Test 2. No microplastic particles were recovered from the wastewater in Test 2, confirming retrofittability and 100% filter efficiency in intercepting microplastic particles as small as 75 microns. The unit cost €17.24 to construct. A cost analysis shows that the metal filters cost €5.55 and a unit housing €11.69. I believe that cost savings would arise in the commercial production of the unit due to the availability of automated manufacturing techniques and savings brought by economy of scale. Following the scientific method outlined, an innovative filtration unit with permanent filters was constructed at a unit cost of €17.24. This unit was retrofitted to an existing domestic infrastructure and tested. In testing, utilizing a control, the unit was effective in intercepting microplastic particles at 75 microns and larger. I believe that it is reasonable to conclude that the project objective was achieved. Thank you for listening. So here, you can see, so this is my project here. This is it on the stand. So this is what it would look like, kind of underneath your sink beside the washing machine. And this here is the project, and you're able to remove them. The filters are removable and very easily cleaned. So you can see this here is the mesh one, and they just slot back in.
Okay, thank you.